Everyone, so today we'll look at this LeetCode question, perform string shift. Okay, so we are given an input string S containing lowercase English letters and also a matrix shift. And shift has two things. One is directions and amount. Okay, so direction can be 0 for left shift and 1 for right shift. Amount is the amount by which string S is to be shifted. Okay, what is left shift? So left shift by ones means remove the first character of S and append it to the end. And right shift means remove the last character of S and add it to the beginning. So let's look at an example. For example, input ABC, shift 0, 1, 1, 2. So the first one is 0, so it's left shift by 1. Here's 1. So it's pop A and append it on the right side. So that's why ABC becomes BCA. 1, 2 means shift right. 1 means right, right? So right shift by 2. Okay, so how it works is firstly, remove A and make it to the left side. So that becomes ABC. And then pop C and append it on the left side. So that's become CAB. And the second example is A, B, C, D, E, F, G. And shift is 1, 1, 1, 1, 0, 2, 1, 3. Okay, so the first shift is 1, so it is right shift. And right shift means we make G into the left side. So, and also another one is also right shift by 1. So F go to the left side. Now it is left shift by 2. So the first two, FG, is remove the first two and append it on the right side, becomes the original ABCDEFG. The last one is also a right shift, so a right shift by 3, which means the last three, EFG, it becomes on the left side, so EFG, and then ABCD. Okay, so intuitively, actually, this question is not super hard, as we can see that the logic is pretty intuitive. So we can have a like intuitive, or let's say a brute force approach. So what is the brute force approach? So we can go like say iterating the entire shift, right? We can iterate the entire shift. And once we see one of the components, we just do operations because the operation is quite simple. There are just two operations, left or right. So we can just like iterate the shift and then do operations like one by one. And lastly, we will have the return the result. I think this approach is not so complicated, but I don't think this is a good approach, right? Because it's really slow, and also you really have to deal with the operations one by one. And also, we need to mention here that actually this is going to be a big O of n because you're iterating through the entire shift. And also, you are doing operations on this input string each time. So this is really a big O of n. So what about, like, let's say we really want to have other approaches. Other approach that's also easier to understand, but also is just faster. Okay, so what's the kind of intuition here? We notice that actually there are only two types of operations, right? Only two types. Only two types of operation. What are these? Left or right, right? So given these kind of conditions, and also for each operation, it's really not like super complicated operation. It's just adding, removing some part and shift it to the left or right. So it's not really a complicated operation. So why not we do like can we like do something that's like only do one operations like once and then get the final result? Can we do that? We all know that addition, right, and also subtractions, this kind of operations are kind of reversible. So same thing applies here. Are they really reversible? Well, actually, let's try. So notice here, example here. Example two is actually a brilliant example. So the first two, 1, 1 and 1, 1. So it's gonna be one right shift and following by another one right shift, which results into this. Okay, and the following operation is actually a left shift by 2, and which makes it to the original string. It's the same as the input string. So that means actually left shift and right shift are like they're kind of reversible operations. So why not we just calculate or count like how many operations, like how many left and how many right do we have, and we can have a final absolute operate number of operation, which is like well, I say absolute, but it can be negative. So if the final result is final count of operation is negative, that means in this condition, I'll just make it left shift. And if it's positive, we'll say the absolute operation is right shift. Okay, so it's just like manipulating some basic definitions and ideas of positive and negative numbers and apply it here. Okay, so I will make a note here. So, well, what we want to do here is calculate. Well, still we need to iterate actually the shift, and we need to calculate the, let's say, pure count. Okay, so what is pure count? Pure count, if it's negative, then which means the final pure shift should be left shift. Well, another condition would be positive. So if it's positive, then the final condition is going to be the final shift is going to be the right shift, or it could be 0 as well, right? When it is 0, then no shift. All right. Okay, so why not let's dive into this algorithm. Okay, so in the beginning, we have two inputs, S and shift, right? So what we want to do is here is we want to calculate the pure shift. Okay, pure shift in the beginning is initialized as 0, and let's make a loop. Okay, actually, I don't want to comment here. It's real coding. Start from here. Okay, so for we want to iterate the two elements inside, right? So for D and A in shift, what's the conditions? If D is 0, which means the left shift, then what we do is pure shift minus A. Also, if D is 1, which means the right shift, then pure shift is plus doing additions here. Okay, so now we have pure shift. But before processing the further steps, we want to do something that is quite more robust here. So pure shift, we want to do a modulo to the length of the input string s, because the value of let's say the value of pure shift could potentially be, let's say, larger than the length of S. We don't want that scenarios, right? That will make these things more complicated. And they actually, um, if we really do that, the final result stays the same if we do the modulo. So modulo really makes things easier. It will have less operations. Oh, well, I won't say it's less operations, to be honest, but if we don't do modulo here, then the following steps would not be valid. Let me see. You'll see why. So, okay, so we do the modulo here. All right. So let's look at this right shift. Pure shift. If pure shift, as we see, is equal to 0, we don't want this pure shift. We that means the output, the return result should stay the same. So we just return S. Okay. What about other conditions? Other conditions, we can return S. Let's think about it. So either left shift or or right shift. That means, okay, let's see. So in the left shift condition, the left part of the string is removed and becomes right part. And also the value of pure shift is negative. So that means we need to start the string from the right side, right? Okay, so how do you start a string from right side? It's become negative pure shift and concatenate it with the original string, but like start from left and pure shift. Okay, does it work also for positive numbers? I mean, positive pure shift? Let's look at it. So if the pure shift is positive, that means we are removing something from the right and add it to the left side. Okay, so that means in the beginning, we're using the right side, right? The right side now pure shift is positive. So negative positive, I mean negative sign before positive. That means that means we're really selecting the right side string, and also here is really starting from the original left side, and the negative sign here with the positive pure shift becomes the original left side part. So it actually works. Let's see. Okay, it's accepted, and let's submit it. All right, it actually works. It's a great news. But before we leave, what's the runtime, right? Well, the runtime, since we still have a for loop, and also is really iterating through the entire list of shift. So the runtime is actually still big of n. Okay. All right. Thank you so much.